Hey everyone, welcome back. Before we dive into the mind-expanding vastness of today's topic, I'm sending out a massive wave of positive vibes and heartfelt wishes to every single one of you watching. Wherever you are in the world, I genuinely hope you're feeling fantastic, taking amazing care of yourselves, and staying healthy. That's truly the most precious thing we have. Now, get ready to have your sense of scale completely shattered, because we're talking about a comparison so staggering it feels almost impossible to grasp. There are more stars in the observable universe than there are grains of sand on all the beaches, deserts, and seabeds of our entire planet Earth. Yeah, you heard that right. Think about every single sandy beach you've ever walked on, every dune you've seen rolling across a desert, every speck of sand beneath the ocean waves across the whole globe. Now, imagine counting every single tiny grain. Astronomers tell us that the number of stars out there dwarfs that unimaginably huge number. It's not just a bit more, it's a cosmic landslide more. This isn't science fiction. It's our best scientific understanding of the sheer, breathtaking scale of the universe we call home, and it's a humbling reminder of just how small, yet how incredibly special, our little blue marble truly is. So, let's try to wrap our heads around this, step by step. First, let's talk about the sand. Sand feels familiar, tangible. We've held it in our hands, felt it between our toes. But how much sand is there really on Earth? To even begin estimating, we need to consider all the places sand exists. The vast coastlines stretching for hundreds of thousands of kilometers, the enormous deserts like the Sahara, the Arabian, the Gobi, covering millions of square kilometers, and the immense amounts of sand covering the continental shelves and ocean floors. Geologists and scientists have spent a lot of time trying to calculate this. They look at the average depth of sand in different environments, the density of how grains pack together, and the total area covered. A commonly cited estimate based on these complex calculations is that Earth holds roughly 7.5 x 10 superscript 1 grains of sand. That's 7.5 quintillion grains. Written out, it looks like this: 7 quintillion 500 quadrillion. That's a 7.5 followed by 18 zeros. It's an almost inconceivably large number. Try to visualize it. If you could somehow count one grain of sand every single second, without stopping day or night, it would take you over 200 billion years just to count them all. That's longer than the current age of the universe. The sheer abundance of sand on our planet is mind-boggling all by itself. Now, shift your gaze upwards, away from our sandy shores and deserts, out into the seemingly infinite blackness of space. We're talking about stars, those twinkling points of light, each one a sun, often vastly larger and more powerful than our own, many with their own families of planets. How do we even begin to count them? We start close to home, in our own galaxy, the Milky Way. Using powerful telescopes and sophisticated methods, astronomers estimate our galaxy contains somewhere between 100 billion and 400 billion stars. Let's be conservative and say 200 billion, 2x10 superscript 1 superscript 1. That's already an enormous number. 200 billion stars just in our cosmic neighborhood. But the Milky Way is just one galaxy. For most of human history, we thought our galaxy was the universe. Then, in the 1920s, Edwin Hubble made a revolutionary discovery using the then-new Giant Telescope on Mount Wilson. He observed faint, fuzzy patches in the sky, previously thought to be nebulae within our galaxy, and realized they were actually entire other galaxies, incredibly far away. The universe exploded in size overnight, conceptually speaking. Suddenly, we knew the cosmos was filled with islands of stars, each containing billions or trillions of suns, separated by mind-numbing gulfs of empty space. So, how many galaxies are there? For decades, estimates were based on deep field observations from telescopes like Hubble. The famous Hubble Deep Field image, taken by pointing the telescope at a seemingly empty patch of sky for days, revealed thousands of galaxies, each a smudge of light containing billions of stars. Extrapolating from these deep fields, scientists estimated there were perhaps 100 to 200 billion galaxies in the observable universe. But technology keeps advancing. Our view got even deeper and sharper with instruments like the Hubble Ultra Deep Field and, more recently, the James Webb Space Telescope, JWST. JWST, with its infrared eyes, can peer further back in time and see fainter, more distant galaxies than ever before. Its early deep field images are absolutely packed with galaxies, 10 times more than Hubble saw in similar patches. This has led scientists to dramatically revise their estimates upwards. The current best guess is that there are likely over 2 trillion galaxies, 2x10 superscript 1 superscript 2, in the observable universe. That's 2 trillion galaxies. Think about that leap, from hundreds of billions to trillions. Now comes the multiplication that truly blows the circuits of your brain. We have an estimate for the number of galaxies, trillions, and an average estimate for the number of stars per galaxy, billions. To get the total number of stars, we multiply these two incomprehensibly large numbers together. Let's use some rounded figures. Roughly 2 trillion galaxies, 2x10 superscript 1 superscript 2, multiplied by an average of 100 billion stars per galaxy, 1x10 superscript 1 superscript 1. Multiplying 10 superscript 1 superscript 2 by 10 superscript 1 superscript 1 gives you 10 superscript 2 superscript 3. So, 2 trillion galaxies times 100 billion stars each equals approximately 2x10 superscript 2 superscript 3 stars. That's 200 sextillion stars. Written out, 200 sextillion. That's a 2 followed by 23 zeros. Compare that to our earlier sand grain estimate, 7.5x10 superscript 1, 7.5 followed by 18 zeros. The difference in the exponents, 23 versus 18, is crucial. It means the number of stars, 10 superscript 2 superscript 3, is a factor of 10, which is 100,000 times larger than the number of sand grains, 10 superscript 1. Even using more conservative estimates for galaxies, say 100 billion, and stars per galaxy, say 100 billion, you still get 10 superscript 1 superscript 1 10 superscript 1 superscript 1 equals 10 superscript 2 superscript 2 stars, which is still 1,000 times larger than the sand grain estimate. 10 superscript 2 superscript 2 / 10 superscript 1 equals 10 equals 10,000. Whether it's tens of thousands or hundreds of thousands of times more, the conclusion is inescapable and staggering. There are vastly more stars in the observable universe than grains of sand on Earth. It's essential to pause here and understand what observable universe means. It's not the entire universe, it's just the part we can potentially see. Because the universe has a finite age, about 13.8 billion years, and light travels at a finite speed, the fastest anything can go, we can only see the light that has had enough time to reach us since the Big Bang. There are galaxies so far away that their light hasn't reached us yet, and there might be vastly more universe beyond what we can ever observe. The actual total number of stars, including those in the unobservable universe, could be infinite or at least immensely larger than what we've calculated. But even sticking strictly to the observable universe, the part we have evidence for, the number of stars utterly dwarfs the number of sand grains on our planet. This comparison isn't just a fun fact, it's a profound statement about the scale of reality. Why does this matter? What does this mind-bending number actually do for us? On one level, it's pure, unadulterated awe. It forces us to confront our place in the cosmos. We live on a single planet, orbiting a single star, in the suburbs of one galaxy among trillions. Every star in that number represents a potential sun, potentially with its own planets, some of which might harbor oceans, atmospheres, and maybe even life. The sheer abundance suggested by that number makes the existence of life elsewhere in the universe seem almost statistically inevitable. It fuels our curiosity and drives the search for exoplanets and extraterrestrial intelligence. On a deeper level, it's a testament to the power of science and human curiosity. We started by counting grains on a beach and ended up calculating the abundance of suns across billions of light years, using mathematics, physics, and engineering marvels like the JWST. We've taken the faintest whispers of light from the edge of time and transformed them into an understanding of cosmic structure on the grandest scales imaginable. This comparison also highlights a beautiful cosmic connection. Those stars, those distant suns, are the crucibles where the very atoms that make up our world and us were forged. The hydrogen and helium born in the Big Bang were cooked inside the cores of stars into heavier elements like carbon, nitrogen, oxygen, and iron, the elements of rocks, water, air, and life itself. When massive stars died in supernova explosions, they scattered these elements into space. This stardust eventually coalesced into new stars, planets, and, on at least one small world, living creatures capable of looking up and wondering about the stars. The calcium in your bones, the iron in your blood, the oxygen you breathe, they were all created inside stars that lived and died long before our sun ignited. So, while the number of stars is incomprehensibly vast, we are physically connected to them. We are, quite literally, made of stardust contemplating the star factories of the cosmos. The next time you stand on a beach, letting the sand trickle through your fingers, remember this incredible scale. Each grain under your feet is one tiny part of our planet's story, weathered from mountains, carried by rivers, shaped by waves. And as you look up at the night sky, even if you only see a few hundred stars with your naked eye due to light pollution, remember that each visible star is just the closest neighbor in an ocean of hundreds of sextillions. Imagine holding a single grain of sand that represents the visible stars. The entire beach stretching out before you, every dune in every desert, every grain beneath every ocean, that represents the stars we can't see, filling the observable universe. It's a perspective that is simultaneously humbling and exhilarating. It tells us we are incredibly small, occupying a vanishingly tiny speck of space and time. Yet, it also tells us we are part of something vast, ancient, and astonishingly beautiful. We possess the consciousness, the curiosity, and the ingenuity to look out, to measure, to calculate, and to understand, at least in part, this magnificent, star-filled reality we inhabit. That ability to wonder, to seek, and to comprehend the seemingly incomprehensible is perhaps the most remarkable thing of all. So, cherish that feeling of awe. Let it sink in. The universe is grander, stranger, and more abundant than we can fully imagine, and we get to be here, right now, trying to grasp even a tiny piece of its glory. Thanks for contemplating the cosmos with me today. Stay curious, stay healthy, and keep looking up.